Hello, everyone. So my name is Viet. I'm the CTO of Hypefactors, and hello from Copenhagen, everyone. We are like a small media intelligence company, and with media intelligence, it means just a moment. Where's my slide? Here. Here we go. So with media intelligence means that we are mining the media landscape ongoingly for all various use cases, like product launch tracking and such. And a long time ago, I chose to base our infrastructure around the JVM for the reasons that Adam mentioned in his talk. We find the developer experience very good. This built-in profiler, static typing makes refactoring really nice at large scale. There's a big ecosystem of reusable components. And if you want to make your own, you can do interop to the C foreign function interface. And we've built like a whole web crawler around it across 8 million sites. And all our data pipelines are, as a consequence, built around it. So like how that looks in our infrastructure today is that we get all these different data sources, websites, printed newspapers and magazines, television and radio broadcasts, and social media posts into our system. And we turn that into business solutions like product launch tracking. We track also trust and reputation, or share of voice to see how you are faring compared to your competitors. And there's much more that you can actually mine out of the media landscape because it's like an ongoing information generation engine. Now, under the hood, this is powered by JVM for the majority of it. And we've been doing that for quite a while. When we were much smaller, it only made sense to enrich this data that we get at these websites and all the articles selectively. We did it with API because it was the fastest way to do it. But then we started to make our own models to customize and to be more spot on with these enrichments. And now we've grown to such a point that we're practically now enriching 50% of our data intake. So we are now migrating to a system that principally enriches all data that comes in. And that leads us to a big engineering problem because we calculated it goes into like a few billion GPU inferences per day. Another thing is that like then our product features are, they are driving on it. So this suddenly like the machine learning and all this model around it are not like nice to have. They become an essential part to keep everything up and running. And therefore the criticality of it increased. So how does it look technically under the hood? We get data in all sorts of formats, HTML, PDFs, and then it goes to a pipeline where we use DJL, but it was mentioned by Chin from Amazon, which extracts the ONNX runtime, which also extracts a part of Hugging Face's tokenizers for NLP tokenization. And we use Zyro on top for cooperative multitasking. And that combined together enables us to build a high performance machine learning pipeline where data is being streamed in, enriched on the fly, and then spit out and put in a database that leads to enrichments like readership, named entity recognition, salience, sentiment, and such. And to run this full scale, we use GPU acceleration. Our initial go-to is usually CPU, simply because it's simpler, and we have had pretty good experience of exploiting the AVX 512 instruction sets to accelerate that. But now we've reached a scale where that didn't suffice anymore. And also to horizontally scale it, we looked at a Kubernetes system to do that. The system was launched last week. So it's running, it's humming right now. It is now yielding at peak load over nearly 1 billion inferences a day. And it was quite a challenge along the way to get it running. First of all, we had to make it economical. So we looked a lot at quantization, which is usually our go-to approach. Initially to 8 bits, but in this case, for this model, we noticed it was we lost too much on the effectiveness of the model. 16 bits seems to be the sweet spot where we got like a 3% gain, 3-time gain over not quantizing it. We also ran into conversion errors, ONNX to PyTorch to ONNX conversion errors. So suddenly, like the ONNX model would yield not a number for the same input, whereas the PyTorch model wouldn't. And we saw that actually happening for specific CUDA drivers as well. So it was a little bit like figuring out what's going on. We figured out it was in the end because one layer was converted incorrectly. So we decided not to quantize that layer, and that fixed it all for us. On top of that, we invested a lot of the robustness. We added the CI that's GPU powered because we run into this GPU and not a number issues. We decided to make these issues reproducible easily and to alert them when that happened. Another thing was memory leaks. As Chin mentioned, DJL is indeed, I can also speak from my own experience, very robust. And yet we were unfortunate enough to hit like a very rare memory leak in DJL. And it took us a while to hunt it down. We replaced many malloc implementations to profile that. After a while, we figured it out. And it also really happens because we do quite a lot of pre and post processing. So it was triggering quite fast and basically was unsustainable in our production environment. The drivers match up, and also that it matches up with the container OS drivers. But it's running, we're happy with it. And it's now also served to our clients. And to make sure that it keeps running, we set up a whole Prometheus logic Grafana stack that monitors like a number of inferences latencies, tokenization latency. To do that, then we will get alerted based on that. And so what we're looking next is increasing GPU efficiency of our system. Right now, we seem to be used around 10 to 20% of the GPU. Not sure exactly how that is measured. So we need to dig into that. But we have managed to push it sometimes to 50%. So maybe it's a matter of, let's say, using a TensorRT engine and loading the ONNX model directly into it. We're also looking to add more models. So that means a multi-GPU setup. And the next thing is to ensure the robustness of the whole system. And we're adding more tests, particularly behavioral testing, which needs to be GPU accelerated because there's quite a lot of that. So that's why our GPU CI infrastructure is set in place. If you have any questions about this particular use case, we are users of the ONNX ecosystem, let me know. Reach out to me on LinkedIn or about Hypefactors. I'd be happy to take them. Thank you, everyone.